My name is Kendra McDonald, and I am the CEO of Canada's Ocean Supercluster. Bon matin tout le monde. Mon nom est Kendra McDonald et je suis la PDG du Supercluster Océanique du Canada. Over the last several months, we've had a lot of fun, showcasing different ocean backdrops during our virtual announcements. Sometimes this meant enduring snow, sideways rain, and days so windy you can hardly hear what I have to say. Today, I'm joining you from St. John's Harbour, where there's lots of history and activity, and with weather that appears to be cooperating with us, at least so far. I would like to take a moment to acknowledge the Indigenous peoples of all the lands each of us are on today. We do this to reaffirm our commitment and responsibility in improving relationships between nations and improving our own understanding of local Indigenous peoples and their cultures. From coast to coast to coast, we acknowledge the ancestral and unceded territory of all the Inuit, Métis, and First Nations people that call this land home, and the interconnectedness of our waters. Please take a moment today in reflection to acknowledge the harms and mistakes of the past and consider how each of us can, in our own way, try to move forward in a spirit of reconciliation and collaboration. Over the last year, we have seen a remarkable demonstration of resilience in our oceans and in the people who are working hard to deliver innovative solutions that will help grow our ocean economy in a digital, sustainable, and inclusive way. This means being bold and innovative in an increasingly digital economy, increasing our capabilities, and becoming more globally competitive than we've ever been before. It means tackling some of the biggest challenges in ocean with projects that help drive not only ocean productivity, but also ocean health on the road to net zero. And it means bringing the ideas, experience, and knowledge of all those who want to participate in the ocean economy to deliver the best solutions and outcomes. At a time when others might have pulled back, our members and their projects have continued to prove history right, that some of the greatest innovations happen during times of great difficulty. Today, we are excited to announce 4 new projects with a total project value of almost $11 million, led from Atlantic Canada with partners from across the country. These projects and their teams demonstrate the resilience and innovation that I just spoke about, and we are so proud to add them to the list of Ocean Supercluster projects that show us what's possible when we work together. It's now my great pleasure to hand it over to Minister Seamus O'Regan to bring remarks on behalf of the Government of Canada.
Hey everyone, thanks for having me here today. I wish we were doing this in person. Please God, soon we will be able to. As Newfoundlanders, the power of the sea is not lost on us. Our ancestors came to this land for the ocean around it, and throughout Canada, from coast to coast to coast, oceans present opportunity. Canada's Ocean Supercluster is here to seize those opportunities, and that is exactly what you're doing. Today, I am excited to announce new collaborative projects. These projects involve over 20 partners from across Canada, and they showcase Canada's leadership and capacity for ocean innovation in everything from digital offshore technologies to low-emitting fuel sources to sustainable alternative proteins. All of these projects are led by Canadian SMEs, and that's something that would likely not have been possible without Supercluster support. Altogether, these projects will create close to 300 direct and indirect jobs over their lifetimes, and perhaps even more in the long term. And many of those projects will help us lower emissions. So, congratulations to the project leads, Duction Motors, Modest Tree Media, Wellaptega Marine, and Denova. And of course, to each of their project partners. We want to grow Canada's blue economy, and your work here is absolutely critical. Thank you for the inspiration, thank you for your hard work, and congratulations again to all of our funding recipients.
Thank you, Minister, for your continued support and your remarks. I'd like to now welcome Susan Hunt, Chief Technology Officer at Canada's Ocean Supercluster, to provide remarks and to introduce the projects.
Thank you, Kendra. Good morning and welcome to today's virtual project announcement. My name is Susan Hunt and I'm the Chief Technology Officer of Canada's Ocean Supercluster, and today I'm standing in front of the narrow seating in the St. John's Harbor. Today I am so pleased to be here for the announcement of new projects in Atlantic Canada. I will start with mobile and mixed reality technician and maintenance software. This project is developing an integrated service that centralizes data, including maintenance tasks, live asset performance tracking, training lessons, and record keeping in a remotely accessible, intelligent, and automated digital ecosystem. The project is led by Modestry Media Inc., with partners Rank, Microsoft Canada, and MyTax. The total project value of more than $2.2 million. The Ocean Supercluster will provide nearly $1.2 million in funding for the project, with the balance coming from industry partners. To provide us more detail on our project and how it's advancing the development of Canada's ocean digital workforce, I will hand it over to the mobile and mixed reality virtual technician and maintenance software project.
Hi, I'm Sam Sanerjee, CEO and founder of Modestry Media. Modestry is a Canadian software company with locations in Nova Scotia and New Brunswick. Modestry has over 10 years experience working with global OEMs, centered on helping them accelerate their digitalization initiatives. This project marks a significant milestone in the evolution of data-centric technology to transform the way industry collects and leverages operational and maintenance data.
is known for its marine and industrial gearboxes all over the world. In ships, the gearbox is right in the center of the propulsion system, and we know ship propulsion better than any other gearbox manufacturer. Therefore, we believe that we can offer to our customers decisive operational benefits by digitalization of operation and maintenance. And this is why we have invested quite a bit into digital solutions over the last few years. Together with Modestry, we at RANK aim at significantly increasing availability of propulsion system by digitalization. We are already applying this approach to gearboxes and electric propulsion systems we supply as RANK. However, it can be adopted to cover the entire propulsion system, including diesel engines, gas turbines, and control systems, or even beyond. This will simplify the usability for our customers. Our customers want the information to be complete, reflect the actual configuration, is easily accessible and easy to interpret, and we will further intensify the use of machine learning algorithms. Currently under development is the combination of digital elements that are available today but only individually. With our joint product, Cabin Tech Companion, we will combine monitoring of condition, analysis of the short-term trend data and long-term trends, digital documentation, access to remote expert, and support by virtual or augmented reality into a single digital platform.
Hi, I'm John Weigel, Chief Technology Officer for Microsoft in Canada. I have the privilege of working with innovators across Canada as they build what's next for our great nation. The Ocean Supercluster continues to drive Canadian innovation and community prosperity, strengthening Canada's ocean industries such as marine renewable energy, fisheries, shipbuilding, and port infrastructure. The mobile and mixed reality virtual technician and maintenance software project is an example of the innovation that gives Canada's ocean economy a competitive edge. Working with Modestry Media, RANK Canada, and MyTax, the project leverages Microsoft's HoloLens technology and augmented reality to aid remote operations, improving ocean asset maintenance. It's really exciting to see the intelligent cloud and intelligent edge come together with this project. This project is not only bringing together jobs for the community, it also provides the foundational technology to support the extended oceans ecosystem.
We are thrilled to be working with RANK, Microsoft, and MyTax, and with the support of Ocean Supercluster to deliver the data-driven tech companion to connect technicians and operators in the marine industry to enterprise systems.
Thank you and congratulations to the project team. We look forward to seeing the benefits that this project brings to the marine industry. Next, I am excited to announce the Sustainable Protein for Aquaculture project. This project is creating a circular approach to aquaculture's feed supply chain by developing and commercializing two breakthrough technologies that produce an environmentally sustainable and low-cost protein for the aquaculture industry. The total project value is $6 million. This project is led by Nova Scotia-based Denova, with partners the Centre for Aquaculture Technologies Canada, Natural Products Canada, Dalhousie University, the National Research Council of Canada, COA, and Cook Aquaculture. The Ocean Supercluster will provide more than $2.5 million in funding in this project, with the balance coming from industry partners. To talk more about the Sustainable Protein for Aquaculture project, I will hand it over to you.
I'm Brianna Stratton, founder and president of Denova, a proudly Canadian biotechnology company creating a new sustainable source of protein for aquaculture. We are grateful and excited to participate in this announcement today and to be launching our Sustainable Protein for Aquaculture project in partnership with Canada's Ocean Supercluster. Denova's mission is to create meaningful change in the global food supply chain by shifting manufacturing and purchasing behaviors to sustainable systems, beginning with aquaculture. To achieve this, Denova is developing a high-quality protein source that can fit the cost models and meet the volumes of the world's largest aquafeed manufacturers. We are offering a protein alternative derived from natural bacteria that is bioavailable, low-cost, massively scalable, and most importantly, environmentally sustainable. Committed to a truly planet-conscious solution, Denova is developing and commercializing innovative platform technologies that will turn greenhouse gases into high-quality protein for aquafeed. Using a proprietary microscale technology, de Nova will capture and convert methane gas to supply methanol, the primary feedstock for de Nova's protein production process. This project will support the development and field testing of de Nova's methane capture to methanol technology, and also validate and scale the production of de Nova's microbial protein, facilitating market entry within 3 years. With the current pressures on our oceans and rainforests from high demand ingredients like fish meal and soy, our intention is to provide a disruptive, environmentally sustainable solution to aquafeed manufacturers that will displace the overfishing and deforestation practices that are destroying these precious ecosystems, the life force and lungs of our planet. This project, Sustainable Protein for Aquaculture, brings together a world-class group of industry, academic, and government partners with a shared commitment to create healthier oceans and advance innovative global solutions for the well-being of our planet and the people who live on it. We are very proud to be working closely with the Center for Aquaculture Technologies, often known as CAT, as project partner on the feed manufacturing and efficacy of de Nova's protein product in Atlantic salmon. CAT is a global full-service contract R&D organization that is focused on the application of technologies to improve productivity, efficiency, and sustainability in the aquaculture industry. CAT is home to a unique combination of world-class scientists bringing together complementary expertise in fish health, nutrition, and genetics, working in state-of-the-art facilities to deliver innovative, tailor-made solutions for organizations in the sector. This year, CAT launched the Aqua Feed Tech Center, a pilot-scale feed extrusion facility based in Prince Edward Island to address the industry need for facilities producing small to medium-sized batches of R&D and custom-formulated aquafeeds. This new service provides producers, researchers, raw materials, and ingredients suppliers, as well as aquatic, animal health, and nutrition companies with access to end-to-end services in feed formulation, manufacturing, and final product testing. The Aqua Feed Tech Center complements the existing animal nutrition service offerings at CAT and eliminates the need to outsource projects to multiple providers, allowing clients, like de Nova, to get to market faster. In addition to CAT, we are fortunate to be collaborating with the National Research Council of Canada and their expert fish nutrition team, as well as Dalhousie University and Cook Aquaculture on this exciting fish feed trial. We are also incredibly grateful to receive support from NRC IRAP and ACOA, and for our relationship with Natural Products Canada, who bring depth of industry knowledge and access to a widespread and highly qualified network of resources, investors, and customers. The Sustainable Protein for Aquaculture project is truly an example of successful coordinated collaboration. Canada's Ocean Supercluster is championing a collective effort that will advance breakthrough technologies to address a significant global opportunity from a Canadian base and contribute to growing Canada's ocean economy.
Congratulations on your project, Nova and team. Great to see this move out. For a third project in today's announcement, I am pleased to introduce the transformative split PM hybrid propulsion project. This project, developed by a consortium from Prince Edward Island and Newfoundland Labrador, develop a hybrid diesel-electric system to make hybridization of existing vessels a viable option. This project will provide an advanced permanent magnet technology to offer Canadian and global clients superior, greener, and cleaner propulsion systems with significant emissions reductions. The project is led by Duchamp Motors, with his partners Aspen Canada Associates and Atlantic Advanced Power Technologies. With a total project value of nearly $1.8 million, the Ocean Supercluster will provide $1 million to fund the project, the balance coming from industry partners. To talk more about this world-first technology, I will hand it over to the split PM hybrid.
Firstly, I would like to thank the Ocean Supercluster for the opportunity afforded to Duction to apply for this research assistance in the important area of marine vessel hybridization. Our team is grateful and honored to have had our joint project with our partners at Aspen Kempton Associates chosen to be supported in this manner. The technology being developed in this project is industry-leading and will have a direct impact on decreasing greenhouse gas emissions in the existing fishing and small vessels fleets. Duction is a Newfoundland and Labrador advanced motor design company, founded out of Memorial University in 2017, focused on the electrification of transportation systems, initially with electric jet motors, then direct drive turboprop aircraft, and now small and medium-sized fishing vessels. Globally, the marine industry contributes 80 million tons of carbon into the atmosphere annually. While newly constructed vessels are much more environmentally friendly than traditional ships, the comparative sizes of the existing fleet, approximately 200,000 vessels, to annual new builds, approximately 5,000 vessels, means that significant impact on overall fleet carbon emissions is many years away. One of the answers to this problem, of course, is to hybridize the existing fleet. Creating the technology that reduces economic barriers for vessel owners to embrace greenhouse gas reductions will increase our chances of meeting this target. A couple of the main challenges in hybridizing today's existing fleet are: one, the time out of service that is needed to retrofit ships, and two, the cost and space needed for replacement of propulsion shafts with electric generator motors. This project will fund Duction's research into development of a generator motor that can be more easily retrofitted into fishing vessels for use in various operational modes, such as wharf side loading and unloading, high idle operations on the fishing location, such as pulling nets or lobster and crab pots. Further, much of what we are learning from this fishing vessel technology is directly transferable to larger vessels, such as offshore supply vessels, short-haul ferries, and tugs. This is, for clarity, this is not technology transfer, but it is first of its kind technology in the world, for which, of course, we have applied for patent protection. Some of the benefits of this project are the development of an easier way to hybridize the world's existing fishing vessel fleet, the expansion of Duction's research and development capacity in the province, and we're creating 5 new jobs in Newfoundland and Labrador, with the potential of creating hundreds of jobs in the retrofit hybridization sector. In conclusion, we could not be prouder of being partnered with industry leaders like Aspen Kempton Associates and the Ocean Supercluster, and to be doing it right here in Atlantic Canada. We look forward to advancing work and to beginning to reduce emissions in our industry. Thank you.
Hi, my name is Jason Aspen, CTO of Aspen Kempton Associates. I'm here today to talk about an exciting project we've got with our partner Duction and Ocean Supercluster as a partial sponsor of the project. Our company is a systems integrator and technology company. We were first movers in the hybrid space, developed the first marine hybrid propulsion system on a tugboat. At that time, we also did a retrofit about a year later for hybrid, and we recognized at that time that it's really difficult to do a retrofit without having major disturbances on the shaft line of the propulsion systems. So we started thinking about different sorts of solutions that would allow us to not disturb the shaft line and still enable hybrid technology. With hybrid technology, you've got to put a motor on the shaft line that runs basically in parallel with the diesel engine. So fast forward years forward, and we were working with Duction on another project that was related to the aviation sector. And we started talking about motor design and asked, what do you think? Would it be possible to split a motor and make it so that you could just put it around the existing shaft line? And the gentleman that's in Duction, that's their chief technology officer, Rabi, he said, yeah, I think that we can do that. And we did some more brainstorming and thought about it, and the concept was hatched around this. And now we have a project where we're going to apply a split motor design concept to a hybrid application, and basically we'll be able to save a lot of money as far as developing a hybrid solution on an existing shaft line or existing propulsion shaft line. And the advantages to that is that really, as we decarbonize and make systems hybrid, we have to find economical ways to take a bite out of the carbon footprint for the biggest projects that are out there, the biggest opportunity that's out there, and that opportunity is on existing vessels. New vessels are being made, of course, and we can hybridize those easily, but it's the existing vessels that have the biggest opportunity. And if we can do that in a cost-effective way where there's a payback in less than five years, then we've got something that can take off and we can really make a difference in the world as far as the marine sector goes. So we're excited about this. We're really happy to be partnered with Duction They're a great fit for our company, and we're looking forward to having this new technology out and available to the marine sector in the near future.
This project has the potential to significantly reduce greenhouse gases. We are excited to see it being developed for introduction into the marine industry. For our fourth and final project in today's announcement, I am pleased to introduce the Unmanned Digital Twinning Project. This project, led from Nova Scotia, is developing an innovative product for digital twinning of underwater infrastructure without the need for external specialists working in remote offshore locations. The Unmanned Digital Twinning Project is led by Wellington Marine with partners Whitecap Scientific, Subsea Imaging, and Nova Scotia Community College SeaTac Division. With a total project value of $592,000, the Ocean Supercluster is providing $320,000 towards the project, with balance coming from industry. I will now invite the project team to walk through this exciting innovation.
Hi folks, thanks for joining us today. I'm happy to be introducing an exciting new collaboration between 3 Atlantic Canadian technology companies to allow the creation of digital twins for remote underwater infrastructure without the need for specialized offshore personnel. For those of you who aren't familiar with digital twins, it's essentially a digital model of a physical object, which can be used for a variety of integrity management, dimensional verification, simulations of operational activities, and other general visualization needs. Accurate digital twins can allow asset owners to understand how their asset is currently behaving and predict future performance. Digital twins can be created for large or small items of infrastructure, sometimes complete 3D replicas of a real-world asset, or otherwise based on CAD models augmented with 3D replicas of critical components. The closer the digital twin is to representing the real-world condition, the more confidently it can be used. The market for digital twinning is growing at nearly 50% per year, which means an estimated $500 million market in 5 years' time in the offshore energy, underwater energy sector alone. Digital twins can be created using a variety of techniques, including laser scanning and 3D sonar technology, but photogrammetry, a technique using hundreds or thousands of images of a structure, is the preferred technology for high accuracy results from a moving platform, such as remotely operated vehicles and autonomous underwater vehicles. However, one of the problems associated with photogrammetry is that high accuracy results are not generated instantaneously, as they require computing time. This means you only get confirmation of sufficient image quality hours or days after data collection is completed, when it's often too late to go back to perform additional work. Therefore, specially trained personnel experienced in image processing are generally required to travel offshore to oversee data collection to be confident that the data will be suitable for the intended result. Trained personnel are currently the only method of data quality assurance and control. This project is intended to make offshore data collection for high-quality photogrammetry achievable by minimally trained personnel, removing offshore specialist personnel from remote locations. To meet this objective, we put together a consortium of industry-leading Atlantic Canadian companies, Wellington Marine, Whitecap Scientific, and Subsea Imaging, with further support from the SeaTac team at Nova Scotia Community College. Wellington brings 15 years of experience performing underwater ROV-based digital twinning using photogrammetry techniques, with an extensive client list and project history all over the world. Whitecap Scientific specializes in augmenting ROV general visual operations with their cutting-edge product ROV3D, providing real-time 3D reconstruction of subsea structures for use by conventional ROV crew rather than specialized personnel. And Subsea Imaging is a world-class OEM of underwater cameras, lighting, and remote data streaming applications who will provide the underwater technology to make this all possible. The finished product will then be marketed using the distribution channels of Wellington's parent company, Ashtead Technology, the world's largest provider of underwater technology to the offshore energy industry. The proposed project will essentially merge Wellington's 3D photogrammetry and Whitecap Scientific's ROV3D technology into a single integrated system. While the ROV pilot sees a live 3D reconstruction generated in real time, high-resolution data will be captured simultaneously, allowing for post-processed high-accuracy digital twins using photogrammetry. The real-time 3D reconstruction serves as a proxy of the high-accuracy processed model, providing positive feedback to the user regarding image quality and coverage. This will allow conventional ROV personnel to be assured that they're capturing high-quality data that will be suitable for photogrammetry use. The integrated user interface will have enhanced remote streaming capabilities, allowing clients and other stakeholders to remotely connect to the offshore vessel to provide guidance to offshore personnel, and will include other features to accelerate delivery time for high-resolution processed results. By transitioning photogrammetry from the domain of specialists to conventional ROV and vessel personnel, will allow our clients to cost-effectively digitize their high-value, safety-critical infrastructure without the need for offshore specialists, will advance our proven digital twinning service using a unique competitive advantage, and will facilitate the transition to unmanned operations without jeopardizing service quality. The proposed project participants are each leaders in our respective fields, with proven product lines and deep knowledge of our markets, meaning that we've got the market position and pedigree to achieve rapid commercialization. This collaboration is an opportunity for 3 Atlantic Canadian businesses to work together to create a world-class product with strong technical advantages that will generate ongoing employment opportunities and strengthen Atlantic Canada's export industry. I appreciate your time tuning in, and please continue to follow progress of our unmanned digital twinning project. Thanks.
Congratulations to the project teams. We look forward to the rollout of your projects and checking in to hear about the exciting milestones along the way. The digital, sustainable, and inclusive growth of our ocean economy is one of the most important opportunities of our time. Now more than ever, as we build toward economic recovery and long-term opportunities for Canadians. With 50 projects approved, we will see more than 100 new ocean products, processes, and services made right here and sold to the world. And thousands of direct and indirect jobs created, not including those that have been maintained and may otherwise have been lost. If you would like to learn more about the Ocean Supercluster, please visit our website at oceansupercluster.ca for information on projects, cluster activities, and membership. Also stay connected through our newsletter and by following us across our social platforms. You can keep up to date with the latest on Ocean Supercluster projects in our bi-weekly podcast called A Deeper Dive and our monthly web series called The Career Pivot. Thank you again so much for joining us today. Stay safe and watch for more announcements in just a couple of weeks.